Alright, so when a ball is thrown vertically upward at a speed of v naught, the initial, the ball reaches a max height of h. To achieve the same max height on the moon, by what factor would you need to change your v naught, your initial velocity upwards? And it says that the gravitational field strength on the moon is a 1/6 times the gravitational field strength here. So gravity is basically 1/6 as strong on the moon. So before we even get into the math, because we see by what factor, we know we're going to need proportional reasoning, but before we even get into that, let's try to kind of estimate what the answer is going to be, right? Because if gravity is 1/6 as strong, if you do the same v naught, like if you do the same initial velocity on the moon, because gravity is a lot weaker, it's going to get way higher, right? Because there's less gravitational acceleration. Okay. So we know that in order to get the same height, you kind of need to throw it a little bit slower, right, to get the same max height. Conceptualize that. Make sure that makes sense, because that essentially eliminates d and e. D and e, if we change our velocity by a factor of either √6 or 6, we need to throw it faster. And that is not helpful, because it's going to make it go way higher than our h that we're trying to do, the same max height. We know it's going to be like a fraction, where we're going to need to throw it slower than v naught. So, how do we confirm what fraction that is? That's when we need proportional reasoning. What equation are we going to do proportional reasoning with? Think to yourself, and hopefully you have an answer. Let's actually figure it out together. We know that, okay, we're dealing with v naught and h. So h would kind of be vertical displacement, our change in y, and then we also know that at the top, what is its v final going to be? It's going to be 0 at the top, right? That's its max height. That's when it's not moving for that instant. It's going to switch directions and fall back. So we know v final is 0. Okay, and then the other variable that we actually have is, g moon, the acceleration on the planet, so it's going to be equal to g moon. And what I'm going to write, and I'm going to say negative. Remember, direction matters. In this case, I'm going to say negative is downward, positive is upward. So that's why I'm going to put a negative here. And then also, I can also say it's a negative 1/6 times g, right? Our g, little g, 9.8, because I know it's 1/6 is strong. So I know all these variables. What equation am I going to use? You're going to use the v squared equals, or v final squared is equal to v initial squared plus 2 times acceleration times change in y, or change in x. So v final is going to be 0. So I can just put a 0 there, because 0 squared is 0. V initial squared is v initial squared. And I'm going to, v initial squared plus 2. Now I'm going to say negative 1/6 g. Remember, because the acceleration on the moon is negative 1/6 g times the change in y, which is height, and that's positive, right? Because you're displacing upwards. Hopefully it makes sense why I'm putting 0 here, why it makes sense I'm making this negative, all that kind of stuff, and then we can just subtract both sides by v naught squared plus negative. I'll just do it like this, 1/6 g. I'm just moving the negative out here, because then you can cancel them out. So v naught squared is equal to 2, 1/6 g times h. Okay, so actually what I really should have done is say, well, on Earth, I'm not even going to worry about this 1/6 yet. On Earth, it's just going to be g, right? I mean, that's true. So when I launch my ball with the speed of v naught upwards, I'm going to reach a max height h. When I multiply this g by 1/6, right, I'm no longer going to get h, right? I've changed the equation. Both sides used to be equal, right? Because I know v naught would get me h, right? If I launch it upwards, I'd get a max height of h. When I multiply by 1/6, it's no longer equal. I did something on this side, multiply by 1/6. To make it equal again, I have to multiply this side by 1/6, right? If my gravity is 1/6 as weak, my v naught squared needs to be 1/6 as much, essentially, right? In order to equate them mathematically. Okay, so 1/6, I have to multiply on this side. Let me circle this, right? No, right? Because we're not multiplying v naught by 1/6. We're multiplying the v naught squared by 1/6. In order to see how does v naught change, you gotta move the 1/6 into the square, and that will get you 1 over root 6 v squared. Because then when you distribute the squared, you get back to 1/6 v naught squared. So the answer would be 1 over root 6. Hopefully that makes sense. Yeah, see you in the next video.